Okay, let me continue with earth pressure theories. In fact, I could have used the title stability analysis because stability analysis main component is the earth pressure calculation, and I have in the 3-4 modules I have discussed about earth pressure theories, how to calculate earth pressure. And first of all we have considered active case, passive case, at rest condition, then cohesionless soil, then cohesive soil, level backfill, inclined backfill, then vertical wall, inclined wall, all sorts of things we have discussed. What are the different ways it can be calculated, we have discussed. Now, I will take a few numerical problems to illustrate how to use those whatever we have discussed. And today I will try to take 3 problems one by one, and let me see the first problem. You can see that a retaining wall with smooth vertical back 8 meter high and retains cohesionless soil backfill. Location of water table is at a depth of 3 meter from the top of the wall. Calculate the total active thrust on the wall and its point of application from the base of the wall. The wall retains a horizontal cohesionless backfill with angle of internal friction phi equal to 35 degrees, and the total, this is actually T is missing, and the total unit weight of soil. Okay, unit weight of soil gamma equal to 18 kilonewton per meter cube, both above and below the water table. That means, the wall is something like this, and it is 8 meter height, and it is water table at 3 meter depth. That means, this is 3 meter and this is 5 meter. So, total 8 meter. So, this is the water table, and this is throughout phi cohesionless soil phi equal to 35 degrees, but unit weight actually, though below water table above water table supposed to be sometime may be different, but here in this problem it is mentioned that gamma t for here and here will be same, but when you consider this zone you have to use submerged unit weight, that is there, we will show that application. So, this is the only difference. So, otherwise for calculation of pressure gamma t, total gamma, it will be here whatever value here also same value. It can be different, but for the simplicity we have taken the same value here, gamma t equal to 18 here, gamma t is 18 here, but actually in the calculation here it will be used gamma submerged, which will be 18 minus 9.81. So, that I will show you while solving the problem in the next slide. So, let me take a board. Okay. So, this problem, suppose we have a wall of 8 meter height, and this is 3 meter and this is 5 meter, and then you can find out the Ka value, actually Ka equal to 1 minus sin 35 degrees divided by 1 plus sin 35 degrees. If I calculate, then we get a value equal to 0.27. Now, if I find out the earth pressure, that means from here 0 to suppose 3 meter. So, this value will become gamma times, that means 18 multiplied by 3 multiplied by K, that means 0.27. So, that value if I calculate, it comes at 14.67. Now, so up to this pressure, so this pressure already came. So, this pressure will be constant throughout depth. Now, you can imagine the wall starts from here, and because of that, with the increase of the wall height, how pressure will vary. So, again that will be linear. So, how to find out that one? So, that one will be can be calculated. So, this one actually this value is 14.67 and this value will be equal to 18 minus 9.81 multiplied by 5 multiplied by 0.27. That means, this will be equal to your 11.05. 11.05. So, this is 11.05, this is 14.67, and as I have told you, the water table is here, and we have considered submerged unit weight of the soil for calculation of earth pressure. Now, if this is the case, then the water also will give a pressure on the wall. So, this one will be considered, and this pressure will be water pressure, and this will be equal to 5 multiplied by 9.81. So, this will be equal to 49.05, that is 49.05, all are kilonewton per meter square. So, now this is the pressure diagram is done. So, all pressure will be on the wall like this, this will be like this, this will be like this. So, like this. Okay. So, now I can imagine, that means, there will be one triangle, one rectangle, another triangle, that means 3 triangles and your one rectangle. So, these I can consider as 1, this rectangle can be considered as a 2, this triangle can be considered as a 3, and this triangle considered as 4. So, I can find out now P 1. P 1 will be how much? Actually half multiplied by base is actually 14.67 multiplied by height is 3. So, it will be equal to P 1 actually will be equal to 22.0 kilonewton, and H 1 means actually what? This if I consider this triangle, and this P 1 will be acting somewhere here. So, it is 3 meter, that means 1/3 from here. So, that means 1 meter from here, that means at the base actually it will be 5 meter plus 3 by 3. So, that means it will be H 1 will be equal to 6 meter. Similarly, P 2 will be equal to, it is a rectangle. So, it is having 14.67 and height is 5. So, that gives you 73.35, and your P 2 will be acting at the middle of this. So, 5. So, this will be P 2. So, this will be this is H 2. So, H 2 will be equal to 5 by 2, that means 2.5. Then P 3 will be equal to this triangle, this will be half multiplied by 5 multiplied by the base is 11.05. So, this will be equal to 27.625 and H 3, that means it is acting somewhere here. So, this height H 3. So, this is H 3. So, H 3 will be equal to 1/3 of 5. So, that means 5 by 3, and then P 4 will be equal to area of this triangle, that will be half multiplied by 5 multiplied by 49.05. So, that will be equal to 122.625 and H 4, that means it will be equal to, that means it is acting here. So, H 4 will be this distance. So, this will be H 4, this will be H 4. So, this H 4 will be again 1 by 3 multiplied by 5. So, that means the total P active I can say P 1 plus P 2 plus P 3 plus P 4. If I sum all them, then I will get a total P A actually 245.6. And if I assume the total active thrust acting somewhere here P A, then this height is suppose y bar, then you will be having P A multiplied by y bar will be equal to P 1 multiplied by H 1. So, directly I will write here P 1 multiplied by H 1. So, P 1 is 22 multiplied by 6 plus P 2 actually 73.35 multiplied by 2 is 2.5 plus P 3 actually 27.625 multiplied by 5 by 3 plus P 4 actually 122.625 multiplied by 5 by 3. So, this two will be equal and P A is already known. So, y bar will be equal to your 566.29 divided by 245.6. So, if I calculate this one, you get a value 2.3 meter. That means, the wall actually this is the wall 8 meter height wall and it has water table somewhere here. Now, ultimately I am getting a thrust P A on the wall which will be acting at 2.3 meter from the base, that means here 2.3 meter and P A value equal to actually is your 245.6 kilonewton. So, this is meter. So, now if the 8 meter wall, if it is no water table would have been there, then where it should have been there? The point of application that should have been 8 by 3. So, it will be equal to 2.67. So, that means, because of the water table and the water weight at the bottom. So, it actually pull down the point of application lower side, but if it would have been a dry soil, then the point of application could have been 2.67. So, that is the difference actually through the calculation we can find out. Okay. So, with this let me go to next slide. Then let me go to second problem, and you can see that a returning, as I have told you that water table one case, then another case I have told you that the backfill may be layered. Okay. And layer means top surface will having little loose or soft soil and bottom towards bottom may be dense soil. So, you can similar situation is shown here. Actually, you can see that a retaining wall with smooth vertical back is 8 meter high, retains a 2 layered soil backfill with the following property: 0 to 4 meter depth, then from the top is C 0 phi 30 degrees and gamma 18, and 4 to 8 meter depth from the top of the wall C is actually 0 C is 0, phi is 35 degrees and gamma is 19. Location of water table as a grade depth, that means your this is the wall and this is quasi-less level backfill, and at the just up to mid height the soil having C equal to 0, phi equal to 30 degrees and gamma equal to 18.0, and here actually C equal to 0, phi equal to 35, gamma equal to 19. So, because of this 2 layered soil, I have to find out now what will be the pressure and what is the total thrust, what is the point of application. So, here that means I have to find out what is the K A here, K A 1, I have to find out what is the value of K A 2 here. So, this is the way we have to find out. So, I will go to the next slide and do it. Suppose now you can see that 8 meter height wall and this is the mid height. So, K 1 equal to 1 minus sin 30 divided by 1 plus sin 30, that will be equal to 1 by 3, and K A 2 it will be 1 minus sin 35 divided by 1 plus sin 35. So, that gives you 0.27. So, now actually I can find out from here 0 linearly it will be increasing, and this value will be equal to 4 multiplied by 18 multiplied by 1 by 3. So, it will be yeah, okay. So, P 1 will be equal to 6, it will be 24, and now this will be constant throughout up to depth, and then if I imagine wall start from here, because of the second layer of the soil, what is the value will be there, how it will be varying. So, it will be suppose like this. So, I have to find out this. So, this is actually your 24 and this one will be equal to your 0.27 multiplied by 4 multiplied by 19. So, this is actually is giving you this is give 4 19 point, so 20.52. This is actually 20.52. So, this is equal to 20.52 and this is 24. So, this is 24. So, I can now think of a 3 diagram. This will be one triangle, this will be one rectangle, that is 2, and this is again another triangle 3. So, I can find out now P 1 will be equal to half multiplied by 4 multiplied by 24. Gamma times h multiplied by sorry, this is why I have done 1/3. So, this is not 1/3 k. So, gamma h k, so that will be actually 4 multiplied by 8 multiplied by 1 by 3. So, it will be 24. So, now area will be half into 4 into 24, it will be 2. So, it will be 48 and your P 2 will become your 24 multiplied by 4, it will be 96 and P 3 will be equal to a half multiplied by 4 multiplied by 20.52. So, it will be half 21.4. So, it will be this will be 48 and this will be 95.04, this will be 96 and this will be 41.04, this will be 41.04 and then H 1 will be equal to H 1 actually what? It will be acting somewhere here. So, it will be from here actually, this is actually 4 meter and this distance will be 4 by 3. So, that means your H 1 will be equal to 4 plus 4 by 3 and H 2 will be equal to 4 by 2 and H 3, that means H 2 will be equal to 4 by 2 and H 3 will be equal to, again it will be acting somewhere here. So, it will be 4 by 3. So, you can find out P A will be equal to 48 plus 96 plus 41.04. So, it will be something like 498 or so. Oh, sorry, 185.04 or something like that kilonewton, and then you will have y bar. Suppose the thrust is acting somewhere here and this height is y bar, then you will have 185.04 into y bar will be equal to 48 multiplied by 4 plus 4 by 3 plus 96 multiplied by 2 plus 41.04 multiplied by 4 by 3. So, if I simplify, then y bar will come approximately this will be I can do this, but it will come approximately 2.7 meter. Okay. So, this for this calculation y bar, that means at a that means point of application of the active thrust will be 2.7 from meter from the base. But if it is a single layer, then it is 8 meter height, then what should have been the height? It should have been, see, it is 8, and so if the triangular diagram, so it will be 1/3 height from the, so that means it could have been 8 by 3, then it could have been 2.667. So, instead of 2.667, because of these two layers and minor variation, so height of the point of application of the, it is becoming 2.7 meter. So, this is actually how to follow, actually how to proceed. Then you have to draw the pressure diagram one by one, and then finally, you have to divide into parts, so that you know the area. So, if I take this area like this, then this area somewhat irregular and difficult to find out area and point of CG. Instead of that, I can divide this one, this part and this part, and this is another part. So, all three parts which is consisting of triangle and rectangle, for which CG is known, and if you know that, then step by step calculation I can do to find out the point of application and this. So, next go to the third problem. Third problem is, you can see that as I have mentioned that there can be two layers, and the previous problem what I have taken, both the soil was cohesionless soil, but one soil suppose cohesionless and another soil layer is suppose cohesive. In that case, that is C5 soil, in that case how to do this. So, this problem you can see that a retaining wall 6 meter high supports two layer of soil, each having thickness of 3 meter. The properties of the layers, actually upper layer actually C is 0 and phi 30 degrees, gamma is 18, and second layer C 10 and phi 18. So, you can see the C phi and gamma actually 19. Determine the total lateral thrust and its line of action of the thrust. So, that means it is the 6 meter high wall, and on that you have here C equal to 0, phi equal to 30, gamma equal to 18, and here C equal to 10, phi equal to 18, and gamma equal to 19. So, you have to find out now the pressure diagram and total active thrust, and then finally, you have to find out the your point of application of the thrust. So, let me take a new page and do it, and you can draw, you can see that 8 meter 6 meter high wall, suppose this is the wall, and at the middle actually there is a layer, and you can see that first layer. So, Ka 1 I can find out, Ka 1 will be 1 minus sin phi by, or 1 minus sin 30 actually by 1 plus sin 30. So, this become again 1 by 3, and Ka 2 will be equal to 1 minus sin 18 divided by 1 plus sin 18. So, that become actually value 0.52, and 1 by 3 means 0.3333, you can write like. So, here actually since gamma is 18 and 3 meter. So, it will go linearly. So, this value will be gamma means 18, H means 3, and Ka means 1 by 3. So, this become 18 at this point pressure intensity. Now, when the second layer will start, that second layer how to find out actually? Second layer actually you have to find out when two layer system, your pressure diagram will be equal to sigma active will be equal to gamma H Ka, or you can say instead of this you can say sigma Ka minus 2 C root Ka. So, I have to find out now what is the sigma here. The sigma here actually is nothing but 18. So, if I do that, so if I do this at this point for the second layer, this will be 18 minus 2 multiplied by C was actually how much 10 and root 0.52. So, this become actually the value become it become actually this value become something like 13.658. So, this was 18, this is 18. So, 13.658 will be somewhere here. So, this will be 13.658. Now, from here actually the second layer pressure diagram will be again if I increase the h further, then it will be increasing this way, and this value will become 43.298. This value will become 43.298. So, this is this is the typical diagram for two layered soil. This will be increasing. So, though this transition it looks two different intensity, but for the theoretical calculation purpose, but it should be something in between actually in the actual, but for the calculation purpose we will take this diagram. So, this value 18 and this is 13.658. So, now what I can do, I can also divide this diagram into three parts. You can see here that is 1, this is 2 and this is 3, and then based on that I can find out P 1 equal to half multiplied by 18 multiplied by 3. So, it will be 27, and then what will be the y or h 1? H 1 will be, this is 3 meter. So, and this is 3 meter. So, it will be 3 plus 3 by 3. So, it will be 4 meter. And similarly, P 2 will be equal to, P 2 means this one. So, this is unit 13.658. So, 13.658 multiplied by 3. So, that become the value. So, it is 40.974, and what about H 2? It will be 3 meter. So, 3 by 2, that means 1.5. And what about P 3? P 3 will be this diagram. So, this is this value actually 43.298. So, that will be equal to half 43.298 minus already taken this value 13.658. This is base multiplied by h. So, half base into height. So, this gives you a value equal to 44.46. And what about H 3? H 3 will be 1/3 from this base. So, it will be 1 by 3 multiplied by 3, that means 1 meter. H 3 equal to 1 meter. So, now your P A will be equal to P 1 plus P 2 plus P 3. So, this if you do, then it will become 112, this will become 112.434 kilonewton. This become this value. So, that means now if I consider that resultant acting at a height y bar from the base. So, it will be P A multiplied by y bar equal to P 1 multiplied by H 1 plus P 2 multiplied by H 2 plus P 3 multiplied by H 3. All P 1, P 2, P 3, H 1, H 2, H 3 are value are there. So, I can get y bar equal to, you can say that will be equal to 213.921, 213.921 divided by 112.434, and that gives you a value equal to 1.9 meter. Okay. So, that means the thrust, final thrust will be acting somewhere here 1 meter, 1.9 meter from the base of the wall. So, this is actually there, but if the 6 meter wall is there at a single layer, where should it should have been 6, that means 1 by 3 multiplied by 6, that means 2 meter. So, that means because of this layering, its point of application is came towards bottom actually by 10 centimeter, actually you can see it should have been 2 meter, but it become 1.9 meter. So, this is the step by step procedure. First of all, whatever you have learned through Rankines theory, That means, for cohesionless soil you find out active pressure diagram or passive pressure. Here actually all problem I have solved in terms of active pressure. It could have been passive pressure, wherever I have used Ka, I should have used Kp, then these values could have been bigger actually, no other difference other than the magnitude will change. So, I have shown the application in terms of active pressure, but it could have been done in passive pressure. Instead of Ka, I could have taken Kp. So, now that means by using the active Rankine's theory, you have to draw the diagram, and once you draw the diagram, you have to break the entire diagram into a number of parts for which you know the area. That means, triangle, rectangle, like that you have to divide, and then find out the all component area of the all component, that become the component force P 1, P 2, P 3, P 4, and then if you add them, that become the total thrust. That is one part, and then find out the individual point of application from the base, and then you find out the individual force multiplied by individual distance, and then sum of that, and then divide by the total active thrust, then you will get the point of application from the bottom of the base of the footing. So, that is the way. So, this is actually P 1 H1, P 2 H2, P 3 H3, and this is the total thrust. So, by that I could get the point of application of the loading is 1.9 meter from the base. So, that is 3 application I have shown, some more I will show, and then finally, I will try to show the how to using this you can do the stability. So, this is the simple wall I have. You see, if you give a thrust, then it will have tendency to topple or it may tendency to slide. So, there many things will happen. So, how to find out that factor of safety, some of those calculation analysis I will do in the subsequent lecture. Thank you.